This is lesson 10-3, measures of center. So we're going to be talking about mean and median. You've maybe heard those words before. They're types of averages. And there's actually a third one called mode, which doesn't appear in this section, but I may mention it at some point because it is also important. So let's just start off with where they start us off, measures of center. A data set can contain many values, but sometimes it's beneficial to find a single value that can represent or summarize the entire data set. So like we summarize with graphics and visuals, we can also use these measures of center to be like a summary of the data as well. Measures of center are numbers used to describe the center of a numerical data set. The measures of center you'll learn about in this lesson are the mean and the median, which are both measures of center, but the center is a different thing. So the mean is the sum of the data, if you add up all of the individual data points, divided by the number of data values. So you add them all up, add all of the individual data points, and then however many of those there were, you divide it by that. And then we call this the average. So when we use that word average in math, we usually are referring to the mean. The median, on the other hand, is the data value appearing at the center when the data set is ordered from least to greatest. And a lot of people forget to put the data in order from least to greatest before choosing that middle value, and that will not necessarily give you the right median. So it's important to put those in order. So we're going to talk more about those as we go through this lesson. So here's how to find the mean. One measure of center used to describe numerical data set is the mean, or average, and it is the sum of the data divided by the number of data values. So we already said that. So here's an example. Suppose you have 4 test scores, 86%, 90%, 72%, and 88%. You can find the mean by adding the test scores and then dividing by the total number of scores, which is 4. So we're going to add 86 plus 90 plus 72 plus 88. So once we have that, then we can divide by 4 because there are 4 of those values, and then we can find that the mean is 84. Now, something to note here, the way that they're notating this, if you know order of operations, you would divide first, but just think of it, think of this notation as with this numerator on top, is in parentheses. It's kind of implied parentheses here. So you would add them all up first and then divide by 4. Just want to point that out. All right, so the mean is the balance point of the data. So the dot plot below displays the test scores, and the total distance below the mean is equal to the total distance above the mean. So we calculated that the mean is 84. That came from our calculation up here. And so if we put that in the middle and then we plot those other scores on here, then what it's saying is like if you were to add up the distance from the mean for each of these values on one side, on the right side, and then add up the distance between the dots and the mean on the left side, you're going to get the same amount. So they show you doing that here. 84 is the mean. And so 84 to 86 is 2, 84 to 88 is 4, and then 84 to 90 is 6. If you add 2 plus 4 plus 6, you're going to get 12. On the left side, 84 to 72 is 12. And so you should have 12 on this side and 12 on this side. So if you were to put this on a little like balancy thingy, scale thingy, the idea would be that the mean would be where you would want to balance that so that it would not topple over. Okay, find the mean, example 1. So this is going to give us another example of how to find the mean just to practice. The table shows the recorded high temperatures in degrees Fahrenheit for 6 days in Little Rock, Arkansas. Find the mean temperature to summarize the data. So here's our table. And so we're going to find the mean, which is where our charts in like a science class come from, finding the average, the mean. So move through the steps, find the mean. How many data values are in the set? It's not giving me the thing anymore, so I think it was 6. There were 6 values. Let's see. Yeah, okay. And then here's how to add those up and calculate. So we've got 45 plus 52 plus 45 plus 50 plus 49 plus 47. Add all those up to get 288 and then divide by 6, which is going to give us 48. So the average or the mean is 48 degrees Fahrenheit. And then, oh, what? This is crazy. Okay, so the dot plot confirms that the mean temperature is 48. So you can test this out if you plot these all on a dot, and then you do that distance calculator thingy where you count between the mean and stuff. You should have equal numbers on both sides. So we have 7 on each side in this case. So that's just one way to confirm. All right, you try it, and then we're going to explore how to do this kind of the opposite way. So how to find a missing data value using the mean. So this is going to be like there's one thing missing, but we already know the mean. So you can use a dot plot and a bar diagram to find the missing data value given the mean and other data values. So consider the following problem. Caitlin's first 4 quiz scores are shown in the table. She's got 88, 95, 93, and 80. What score does Caitlin need to earn on her 5th quiz to have a mean quiz score of 90? So this we're trying to figure out this last quiz to see if she wants to get a 90 average. So we can use this dot plot idea to find that balance point. So what we would do here is we know she wants the mean of 90, so we're going to put that in the middle, put that for our mean, and then we're going to plot what we already know, which is 80, 88, 93, and 95. That comes from this table. And then we can calculate these distances from the mean on the left. So 90 to 80, that's 10. And then 90 to 88, that's 2. That gives us 12. And on this side, we've got 90 to 93 is 3, and then 90 to 95 is 5. If we add those up, that's going to give us 8, but we want it to equal 12. So we need to figure out what our missing value is here. We are missing, if we want to get to 12, we need something that will be 4. So that means that we would need our dot to be 94, and therefore her score must be 94 or higher if she wants to get that mean quiz score of at least 90. Okay, so 94 is the exact answer there. You also could do this using an equation. So here's how they represent that visually for you. To find the total amount needed to achieve a mean score of 90, multiply the mean 90 by the number of data values 5. So originally they gave us 4 data values and 1 unknown, but we know that that means that overall we want there to be 5 data values. So we're just going to do this mean calculation kind of in reverse here. So we're going to take 90 as our goal mean, multiply that by 5 data points that we eventually will have, and that's going to equal 450. And then we can add up the sum of the known values, which are the 4 they already gave us. And if you add those up, that's going to give you 356. And then the leftover, we're just using this variable q for quiz. So then we can write the equation. We can go 356 plus q equals 450, and we can use our properties or our algebra to solve these. So if we subtract 356 from each side, then you can find that you're still going to get that answer of q equals 94. So there's 2 ways to do that. You don't have to use the visual to represent that. You can go straight into the equation piece if you want to. All right. So here's one more example using that method. Or doing this process, I should say. We've got the number of messages Alex sent on her phone each month for the past 5 months were 494, 502, 486, 698, okay, and so on. Suppose the mean for 6 months was 532 messages. So they gave us 5, but we are using a mean for 6. How many did she send during the 6th month? So we can use that balance point. We can use this dot plot method here, put our mean of 532, and then plot all our points. This is a little harder to see because they aren't being precise in their numbering down here. but you can still kind of do the math yourself. So they're finding that the distance below the mean totals up to 168, and the distance above the mean on the right totals to 158, which means that the off balance is happening above the mean. So we need to have, we need 10 more. So that means that we need to figure out what that would be. The distances are not the same because the sixth amount is not plotted. There's a greater distance below the mean, so we need something above the mean. So the missing value must be 10 units above the mean because 158 plus 10 is 168. So the missing value, therefore, is going to be 532 plus 10. So that's our mean plus 10, which is going to be 542. Yay. Or you can use the equation, which I think most people tend to prefer this method. So here we go again with, you can use the visual if you like. We know the total messages because we are going to take our mean that they gave us and multiply that by 6, because we have 6 months in total, and that is going to give us 3,192. Then we can add up the values we do have and get our total there, which means that that total plus our unknown total, M for messages or month, will equal the total that we got calc by using the mean. So that will be 3,192. So then we can solve our equation the same way we always do, where we have the equation and then subtract this from each side to get M by itself. And then you can get the value isolated for M. All right, that's mean. So, oh, what happened? There's no check for this? There should be a check for that. It's being glitchy. If there's a check for that, please do it. But let's move on to finding the median, which is usually a little bit easier than mean. So for this median, the key thing here is to make sure you put the data in order from least to greatest first. You have to do that step or it will not work. So then what you need to know is if there's an odd number of data values, like if there's 17 values they give you, then the median is the one that's exactly in the middle, like literally visually in the middle. So you can count from both ends and then just get to the middle. If there's an even number of data values, then you count to the middle and there's going to be 2 that are exactly in the middle. And then you find the mean of those 2 values. So just as the mean is a single value is a summarized data set, the median also summarizes the data set with a single value. So you can't just leave the median as those 2 values. You have to find the mean. Now, if those 2 values happen to match, then that's the median. You don't have to actually find the mean because the mean will be values, but you'll see. Let's practice with it. So here is our data set. They have already put these in order from least to greatest. You are not always going to have that luxury, but they've done that for us this time, which is nice. So since there are 13 different data values, if you count all of these, there will be 13, then that means it's an odd number. So the median will be in the middle, the exact middle. So we can find our median by going like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I landed on 10 at both times, so that is our median. That's the median. Over here, there are 6 data values below the median. And over here, there are 6 data values above the median. So it's nice and easy once it's when it's an odd number. Just make sure you put them in order from least to greatest. Why must it be order from least to greatest before finding the median? Because otherwise you're just grabbing some random number and it's not going to represent the middle of the data. So find the median given an odd number of values. We're going to do that one more time. Between 2009 and 2015, the number of Atlantic hurricanes each year were 3, 12, 7, 10, 2, 6, and 4. Now notice these are not in order from least to greatest, so you must do that first. I know I'm saying that and it sounds annoying, but trust me, people do not do this part and then it does not result in a correct median. So here's this, ordered from least to greatest for us. What that means, so we just went through that fast. Then we're going to find the median. How many data values are below the median? How many are above the median? So this is another odd example. So we have 1, 2, 3, 4, and we have 1, 2, 3, 4. That's going to land on 6. It says shade the value. There it is. And that means that there are 3 above and 3 below. That should always be the case, that where these match. How many data values below and above should always be the same because you're in the middle. All right, and then is this our check? Yeah, so you try that. And now we're going to do it one more time here, but this time they're going to give us an even number of values. So we have one extra step basically. The same idea of this. Oh, no, we're not doing monkeys. The monkeys are annoying. Okay. Because there's an even number of data values. Okay. Oh, that the video is with the data. Oh, that's so annoying. There. Okay, there we go. Here's how many monkeys there are. They are not in order from least to greatest, but they must be before we do this. So let's go ahead and do this. I was going to put that there, but then I saw at the last second. Not to. Okay, you guys know this part. You know how to count. So you got to do it though. You have to do this part. Trust me. Try and not do it. You have to write it out. You're going to get confused. All right. So there are 10 of those values. And so if we were to count from the outsides, the left and the right, like I have been, you're going to find that you're going to land on two different numbers, 25 and 27. So in order to find the true median, we need to find the mean of 25 and 27. To do that, we add them together and then we divide by 2 because there are 2 of them. And that's going to give us 52 divided by 2, which is going to be 26, which happens to be right in the middle of these two numbers as well. So sometimes you'll see patterns like that and you can kind of make it go faster. Okay, so in summary, there are mean, which is the average. You add them all up and then you divide by however many you added up. And then there's median of an odd number of lists. So you got to put them in order from least to greatest and then find the one that's exactly in the middle. Or if it's an even number of data, to find the median, you still put them in order from least to greatest, find the 2 in the middle, and then find the mean of those 2 to get the true median. And that is how you do that. So try this check, and that's the end of this lesson.